Find the volume of the solid formed by revolving the region bounded by the curves y equals negative x plus 2, x equals 0, and y equals 0 around the x-axis. Leave this answer in terms of pi. So this is what we're dealing with. We're dealing with this equation right here graphed out, right? Okay, so what's going to happen is we're going to take this line, we're going to spin it around the x-axis, and by spinning it around the x-axis, we are creating essentially a cone that is going to be a solid shape. Okay, that's what we're doing here by spinning this around the x-axis. This method is called the disk method. And the disk method is calculated by taking the integral from your lower limit, we'll figure that out in a minute, to your upper limit, we'll figure that out in a minute, times pi times f of x squared. Now essentially what we're doing is we're saying pi times f of x squared. F of x, that black line right there, acts as a radius at different spots of our equation. So if you're looking at this and thinking, wait a minute, if f of x is like a radius, isn't that pi r squared? Isn't that the area of a circle? Yes, it is, because we're spinning something around. And when we take the integral of an area, we're finding the volume. So essentially what we're doing this is we're cutting this into infinite amount of circles, stacking them up as if they're disks stacked on top of each other, and calculating the volume that way. So what we need to do is we need to find our limits before we do anything. Now our limits are going to be from 0 to 2. How do I know that's 2? Well, I need to find out what my 0 is, and my 0 is found by taking u, setting that equal to 0. So if I have negative x plus 2, set it equal to 0, add x to both sides, 2 is going to be my other limit. Okay, so I'm caring about this cone essentially from 0 to 2. So I'm going to set the integral from 0 to 2, pi times that function f of x, negative x plus 2 squared dx. So before I do anything, let's rip out that pi, okay, because it's a constant, or coefficient. This is a perfect square trinomial, so if you were to FOIL that out or do the whole perfect square things, you would get x squared minus 4x plus 4 dx. And now we can integrate. Okay, pi still lives out there. The integral of x squared is 1/3 x cubed. The integral of negative 4x is going to be negative 2x squared. And the integral of 4 is going to be 4x. Ooh, that was a close one. Oh boy, that was a close one. That was a close one. That was a close one. My limits are still 0 and 2. So let's plug stuff in. Pi times 1/3 2 cubed minus 2 times 2 squared, another close one, plus 4 times 2. Let's use common sense. If I were to plug in 0, I would get 0 minus 0 plus 0, which is 0 times pi is 0, so you're 0. We're not going to lose sleep over that. So now it's just a matter of doing that little bit of math right there. Pi times 2/3 is 8. So 2 to the third is 8, so that becomes 8/3. Okay, minus regular 8 plus regular 8. Oh, happy day, you cross out. So much crossing out. And at the end, we get 8 pi over 3. That's the disk method. Find the volume of the solid formed by revolving the region bounded by the curves y equals the square root of x, x equals 1, and x equals 4 around the x-axis. Leave your answer in terms of pi. So y equals the square root of x is going to look like this. What I'm going to do is I'm going to take this part to this part, and I'm going to take that little circular looking chunk and I'm going to spin that around the x-axis. And what's going to happen is I'm going to end up with this weird bowl-like figure that's going to be a solid. But that looks just awful. But what we do get is this solid bowl looking thing. So the method that we are going to use to do this is called the disk method. The disk method is found by taking the integral from your lower limit to your upper limit, so in this case from 1 to 4, and we're going to take the integral of pi times f of x, which is going to be the original equation that you're using, squared. And if you're looking at that and saying, wait a minute, that is kind of like pi r squared, isn't it? It is, because essentially what we're doing is we're cutting this part into infinite amount of circles and then stacking them on top of each other to find the volume. That's why this is called the disk method. All right, so setting this guy up means why don't we rip out the pi? My lower limit is 1, my upper limit is 4, and I'm going to square the square root of x. Oh, happy day. That's going to make life so easy because it's just going to be x dx. Okay, so the integral of x is going to be 1/2 x squared. My limits are still 1 and 4. That pi is still living outside. Now I'm going to plug in 4 and 1. So pi times 1/2 4 squared, a fun game, minus pi times 1/2 1 squared. You become, let's wave our hands a little bit, 4 squared is 16, half of that is 8, so pi times 8, minus 1 squared is 1, half of that is still 1, so pi times 1/2, not 1, but 1/2. That's 8 pi minus half a pi, which is going to be 16 over 2, 15 halves pi, or 15 pi over 2, which is B. Find the volume of the solid formed by revolving the region bounded by the curves y equals negative 1/2 x plus 2, x equals 0, and y equals 0 around the y-axis. Leave your answer in terms of pi. Well, if we're doing the y-axis, we need to solve u for x. So that's going to be step number 1. Y equals negative 1/2 x plus 2. Solve for x is going to have me subtracting 2 first. So that gets me y minus 2 equals negative 1/2 x. Let's multiply both sides by negative 2. Multiply both sides by negative 2, so that's distributed property. Negative 2y plus 4 is going to equal x. So let's write it out that way. Okay? Happy day, happy day, happy day. So basically the picture that we're getting is going to be this equation, right? This equation spun around the y-axis. So we're looking at this like upside down cone looking thing that's going to be created when all is said and done. Okay, look at that picture. Perfect. So what do we care about? Well, we care about the fact that we're shutting this down at 0, and we need to find what this guy is going to be up here, which I already know, because that guy up there is going to be 2. That's my y-intercept. So my limits are going to be 0 and 2. So usually I focus on my limits being on the x values, but in this case I'm focusing on my limits being the y values because I'm spinning this around the y-axis. So my limits are going to be 0 and 2. Now this is using what's called the disk method. The disk method says we take our limits and we integrate pi f of x, or in this case f of y, squared dy. You are my new f of y. My limits are going to be a and b, which are 0 and 2, and I'm going to have pi, and I'm going to square everything. So let's set that guy up. Okay, let's rip out the pi. My limits are 0 and 2. I'm going to have negative 2y plus 4 squared dy. Let's pull out that pi. I already did. Pull out that pi. Before I integrate, let's FOIL that out. Okay, that's a perfect square trinomial. So you become 4y squared minus 16y plus 16 dy. Now let's actually integrate that. Okay, 4y squared becomes 4/3 y cubed. Negative 16y becomes divided by 2, 8y squared. And u becomes 16y with my limits living at 2 and 0, not in that order. Let's plug in 2. Pi times 4/3 2 cubed minus 8 times 2 squared plus 16 times 2. Now let's use some common sense. 0. Why? Well, if I were to plug in 0 into u, I'd get 0, and then u would be minus 0, and then you would be plus 0, and then timesing pi is still going to be 0, so nothing changes. I'm just left with this guy right here, so it's going to involve me simplifying stuff. 2 cubed is 8, so I have pi times 4/3 times 8 minus 8 times 2 squared, which is 4, plus 6 times 2, or 16 rather, times 2 is still 16 times 2. I don't know why I just didn't say 32, but I said no. You become pi over, not yet, sorry, jumping the gun. You become pi, what is that, 32 over 3 minus, oh, no way, 32 plus 32, so you guys cancel out, and you become 32 pi over 3, which is D. Isn't that fun?